Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Electricity Part C. Okay, here we are going to solve each and every numerical. Before that we have solved Part A numericals, Part B numericals, Part A concept video, Part B concept video and Part C concept video, and we have solved all the theory questions from all the chapter. All those videos are available in the description box. Watch them and learn it properly. Okay, so all these things we have explained in the theory concept, correct? And we have used some of the formulas in solving questions also, while solving questions also. Now before solving our first question, we need to understand all the terms and their units, okay, and when to substitute in different format, all those things. Listen, V is equal to IR according to Ohm's law, that we know. Power is equal to V into I. This is the primary formula. You see, using this primary formula we have derived all these power formulas, correct? So you don't have to by heart all these things in the exam. If you know how to derive all these things, that is what I have taught in concept video. Next, H is nothing but heat generated. How much heat energy is generated? I square R into T. Time should be in terms of seconds when it comes to heat energy generated. Next, energy consumed. EC means energy consumed, that is equal to power into time. Power should be in terms of kilowatt and time should be in terms of hours. Keep this in mind. Okay, when it comes to energy consumption, power should be in terms of kilowatt. How we can convert normal watt into kilowatt? Divided by 1000. What do you mean by watt? Watt is the unit of power. Okay, if you want to convert watt into kilowatt, divided by 1000. Next, time should be in terms of hour. Most of that, see, when it comes to energy consumption, in the question only they'll give you the time value in terms of hours, then you have to substitute in terms of hours only. Next, electricity bill generation, that will be equal to whatever the energy consumed into number of days, for how many days it has used, into rupees. What is the value for 1 kilowatt hour? 1 kilowatt hour, that will be given in the question. We just have to multiply, we'll get the electricity bill for that appliances. Okay, now how many appliances they are going to give? For all those appliances we are going to get the bill for respective data. Now without wasting any time, we'll start with the first question. An electric bulb of resistance 500 ohm draws a current of 0.4 amperes. From the source, calculate power of the bulb and potential difference at its end. Okay, listen, very simple question. First we'll write the given data. Resistance is given, that is 500 ohm. Current is given, that is 0.4 ampere. We need to find power. We need to find potential difference. PD is nothing but voltage only. Okay, first we'll find power. Okay, listen, we need to find power. What are the given data? I into R. See, power has three different formulas. We have I and R. Out of these three, which has only I and R? The second one, correct? We'll use that formula. I square R. What is I? That is 0.4 into 0.4 into R. R is nothing but 500. So this will be 0.16 into 500. 16 5s are 80. For two zeros, two decimal point will go. What is the unit of power? Watt. See, this is my method of calculating. You can use any method, will get the same answer. Next, we need to find, this is the first sub question. Second sub question, we need to find voltage. When I and R are given according to Ohm's law, we can also find the answer. V is equal to I into R. I is nothing but 0.4. R is 500. 4 5s are 20. Next, for 1 0, one decimal point will go 200 volts. That's it. Again, this is my method. You can use any method to calculate. See, if you know the formulas, if you write what are the given data, aram you can solve all the numericals. But make sure you are writing the proper units. See, for power, unit is watt. For voltage, unit is volt. If you miss any one of the units in the board exam or anywhere, okay, in your school, they have to deduct marks. If they are not deducting marks, means they are doing something wrong. That is going to affect you in the main exam. So in the main exam, for every wrong unit, okay, they are going to deduct 1 mark. Assume there is a question in that question you are going to find four parameters in that numericals. All the four parameters have four different units, correct? If you miss that 4 units, the question is only for 4 marks, you will lose all the 4 marks. Keep this in mind. So units are very much important. Our second question, a current of 2 ampere is passed through a coil of resistance 75 ohm for 2 minutes. How much heat is generated? How much charge passed through the resistance? See, first we'll write the given data. Current is given, that is nothing but 2 amperes. Next, resistance is given, R is equal to 75 ohms. Time is given, that is for 2 minutes. Okay, now we have to find how much heat energy is produced. H we have to find now, and how much charge is passed. Charge is nothing but Q. This we need to find. Now we'll go for the first sub question. This is A, okay, this will be B. H is equal to, see, we need to find H. H has only one formula. H is equal to I square R T. I square R into T. Okay. Here, first marks will not be given for the formula. See, in ICSE, keep this in mind. For formula, there is no mark, but you have to write the formula. In the formula, next step we are going to substitute the values. Correct. Next step we are going to substitute the values. First mark is always given for the substitution. Okay, this is what they told us while correcting your board exam papers. So key answers, in the key answers they will give us first mark is always given to the substitution. Keep this in mind. Next, I square. First we need to find I square, R 75, time 2 minutes. If you substitute 2 here, the first mark which is we are going to give completely will be deducted. Why? Because time should be in terms of seconds. Correct. When it comes to heat energy generated, it should be in terms of second, except energy consumption, the time should be in hours. Apart from that, everywhere time should be in terms of seconds. So 2 minutes is given, 2 into 60, that is 120 seconds. Now first mark is given here only. Next, 4 into 75 into 120, that is equal to 36,000 joules. See, if you convert time into seconds, answer will be in terms of joules. Second sub question, we need to find Q. How we can find Q? There is no formula for Q. Do you remember in the first chapter, first part of numericals, we learned I is equal to Q by T. I is equal to Q by T. So Q is equal to I into C. See, this is the first formula we learnt in electricity numericals. Correct. First formula, I is equal to Q by T. Correct. If you want Q, just send this T this side, so that becomes I into T. I is given as 2, time is, you have to take it in terms of seconds only, so that will be 240. What is the unit of Q? That is C. That's it. Question number 3. Calculate the current through 60 watt lamp rated for 250 volt. If the line voltage falls to 200 volt, how is power consumed by the lamp affected? Listen, very simple question. First, listen, they are asking us to find current using 60 watt lamp power and voltage. Now they are reducing the line voltage. What do you mean by line voltage? Line voltage means the supply voltage, that is nothing but 250. If you reduce the 250 volts to 200 volts, what is the new power? How much power now the lamp is consuming? That is what we have to find. First they have given, first we'll write the given data. Power is given as 60 watt and voltage is given 250 volts. Okay, using these two we need to find the current. That is what he is asking. Once we find current, now they are going to reduce the voltage to 200 volts. Whatever the voltage they are giving, 250, line voltage is nothing but supply voltage only. That 250 volts is reduced to 200 volts. Now what is the power? Okay, see, first we'll solve this one. This requires some logic, I'll explain, and then we'll go for the second sub question. See, we need to find I using power and voltage. See, this is the formula, correct? In this formula, aramse we can find current. So I is equal to P by V according to that formula. Next, what is P? That is 60 by 250. So answer will be 0.24, what we are finding? Current, that will be in terms of amperes. Okay. Now the second sub question, V is equal to, they have given voltage and we need to find power. Just now we have found current, correct? Current into voltage, we can aramse find the power, correct? See the second formula, P is equal to V into I. Just now we got I, we have V, we can aramse find power, correct? That is completely wrong. Why? Because there is a change in voltage. So current will also change. This current what we found is for this voltage. We cannot use the current what we found here into V to get power. That is completely wrong. Then what we can do? Very simple. We need to find the resistance of the wire. Why? Because see, we have one more formula. This formula requires current. That current whatever we found, that is for this voltage. Now we cannot use this one. Okay. Then we have to use this one because they have given voltage value. We need to find resistance of the wire. Aram then we can substitute and get the answer. So how we can find the resistance of the wire? Resistance of the wire is nothing but V is equal to IR. Go for the Ohm's law only. Okay. In Ohm, second one, we need to find first resistance. Resistance is equal to voltage into voltage divided by current. Sorry, voltage divided by current. See, we are finding the resistance of first case only. The same value will be here. Why? Because we are finding the resistance of the wire. The resistance of the wire will not change, correct? So V is equal to 250 and I is equal to 0.24. The answer will be 1041.6. What we are finding? Resistance. So that will be in terms of ohms. Next, once we find the resistance, we'll substitute this resistance and voltage to find the value of power. So using V and R, which formula? P is equal to V square by R. V, we know that is nothing but 200 square by R. What we found? That is 1041.6. Okay, when you calculate this, simplify this one, power will be 38.4. What is the unit of power? That will be watt. That's it. Question number 4, very easy question. An electric bulb is rated 100 watt and 250 volts. How much current will the bulb draw if it is connected to 250 volt supply? So first we'll write the given data. Power is equal to 100 watt, V is equal to 250 volts. Correct, we need to find the value of current. So I is equal to, see, we have three things: power, voltage and current. Which formula? The second formula, correct? In that formula we need to find current. So that will be equal to power by voltage. Power is equal to 100 divided by 250. So answer will be 0.4 amperes. That's it. See, this is what they are asking. Question number 5. This is also a very easy question. An electric bulb is rated at 220 volts and 100 watt power. What is its resistance? What is the safe current can be passed through it? Very simple. Listen. Question number 5. Power is given, that is nothing but 100 watt. Voltage is given, that is nothing but 220 volts. We need to find value of R and we need to find value of I. That's it. So first one, R is equal to, see, using power and voltage, which formula? The fourth formula. Power is equal to V square by R. So here, but we need to find R. So it will be V square by P. V square is, so it will be 220 into 220 by, what is the power? 100. For two zeros get cancelled. 22 into 22, that is 484. What we are finding? Resistance. So that will be ohms. That's it. See, if you know the concept, voltage is voltage square. You should not substitute only 220 by 100. You will definitely get answer. That will be completely wrong. Next, I we need to find. Using power and voltage, we can, how we can find current value? So P I is equal to, see, using voltage and power, how we can find current? The second formula. So in the second formula, I is equal to P by V. Power is equal to 100. Voltage is equal to 220. So 100, 0 get cancels, 2 5s are 2 11s are, this will be 0.45. What we are finding? Current. So answer will be in terms of amperes. That's it. Question number 6. A bulb of power 40 watt is used for 12.5 hours each day for 30 days. Calculate the energy consumed. Okay, electrical energy consumed. See, this is also very easy question. We have the formula. We'll substitute and get the answer. Okay, this is question number 6. A bulb, the power is 40 watts. Power is equal to 40 watts. Next, used each day. Okay, time is given as 12.5 hour. Then it will be 30 days. So number of days. Okay, number of days is equal to 30. Okay, we need to find EC. See, in the exam don't write EC. Okay, there is no term called EC. I have done it just to save the space. See, EC is nothing but energy consumed. So what is the formula? EC is equal to power into time. See, this formula we have to use when the number of days are not given. If the number of days are given, just multiply it for how many number of days. If they are talking about 1 month, always you substitute 30 days. Okay. So P into T, and this should be in terms of kilowatt. Keep this in mind. And time should be in terms of hours into number of days. Okay. See, in the formula there is no number of days, even though I am using it. If number of days are not given, then you have to assume it as 1. Okay, that's why I have not written here. If number of days is given, just multiply it, you will get the final answer. Power, see, power is in watt. Okay, we need to get the answer in terms of kilowatt. So 40 divided by 1000 into time is given in terms of hours, that is 12.5 for 30 days. Okay, for 10 10 10 10. Next, 2 2s are 2 5s are. So what we have left? What is left? 2 by 5 into 12.5 into 3. So answer will be 15. What we are finding? Energy consumption. And what is the unit? Kilowatt hour. Kilo, small k, very important. If you write capital K, that is different. Small k, capital W, small r, small h. Okay, so this is very much important. That's it. You can go for any method of calculating the answer. Answer will be same. Question number 7. An electrical press is rated 750 watt and 230 volt. Calculate the electrical energy consumed by the press in 16 hours. See, here number of days are not given. Assume it as 1. So we'll write the given data. Question number 7. So power is equal to 750 watt and voltage is equal to 230 volts. See, if you want to understand, when it comes to electricity chapter, if you want to understand it properly, whatever the appliances you have in your home, use all those things there, you will understand it practically. So not only learning theory, anyone can do this one. Applying this one in your home, we are using electrical energy, right? Apply this one and find the values of your rated power, all those things for your machines and whatever you have. So you will understand it properly. Now we need to calculate the energy consumption and by the press in 16 hours. Time is given as 16 hours. So now we'll apply the formula. EC is equal to P into time. Number of days are not given, assume it as 1, so no need to write it. P should be in terms of kilowatt and time should be in terms of hours only when we are calculating the energy consumption. Okay, power is 750, that is in watt, converted into kilowatt divided by 1000 into time, that is nothing but 16 hours. So for 1010, then 75 divided by 100 will be 0.75 into 16. You multiply it, will get the answer as 12. So if you are finding energy consumption, that will be in terms of kilowatt hour. Okay, in few questions we are going to get the answer in terms of joules. When, see how we get to know whether we have to keep the energy consumption in kilowatt hour or in terms of joules. If the values, okay, if in the values, if the time is in terms of hour, okay, the final value will be in terms of kilowatt hour. But if the time is given in the question in terms of minutes or seconds, the same energy consumption will be in terms of joules. That's it. Question number 8. An electrical appliance having a resistance of 200 ohm is operated at 200 volts. Calculate the energy consumed by the appliance in 5 minutes in terms of joules, in terms of kilowatt hour. Now, first we'll write the given data, then we will go for the question. See, R is given as 200 ohms and V is given as 200 volts. Correct. Now we have to find the, and time is also given, that is in 5 minutes. We have to find the energy consumed in terms of joules and energy consumption in terms of kilowatt hour. Okay, now listen. Energy consumption, we have to find it in two formats, one in terms of joules, one in terms of kilowatt hour. See, we got to know how to find in terms of kilowatt hour. Power should be in terms of kilowatt and time should be in terms of hours. When you want to find the energy consumption in terms of joule, power should be in terms of watt, power should be in terms of watt, and time should be in terms of seconds. Okay, and once we find the answer in terms of joules, there is one relation between joules and kilowatt. We don't have to calculate the value of energy consumption in kilowatt. We can use the conversion from joules to kilowatt hour. We can find the answer easily. First we'll find the answer of energy consumption in terms of joule. To find that, we need power. Correct. Power is equal to, what are the given data? Resistance, voltage and time. So power is not related to time here. Correct. Now it is related to only voltage and resistance. Which formula? Fourth formula. So here V square by R. Correct. V square by R. V is nothing but 200 square by R, that is 200. So for 200 will go off. See, 200 square will be equal to 200 into 200 divided by 200. So power is equal to 200, that is nothing but watt. Now we'll go for the first sub question. Okay, in terms of joule, energy consumption in terms of joule, power should be in watt, time should be in terms of seconds. So 5 minutes means 5 into 60, 300 seconds. Now EC, right? So here power into time. See, they are not talking about number of days. So number of days, we'll assume it as 1. Power is 200, time is 300. 2 3s are 6 joules. That's it. Next, power in terms of kilowatt hour. See, you can go for calculation method also, or there is a conversion. There is a relation between joules and this one kilowatt hour. We can go for it. Anyhow, we have learned the calculation method. Now we'll go for relation. Listen, 1 joule, okay, 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. Okay, now we have the answer in terms of joules. We have to convert this joules into kilowatt hour. So whatever the joules we have divided by 3.6 into 10 power 6. Okay, we'll get the answer in terms of kilowatt hour. So to convert the answer, whatever we found in electrical energy consumption in terms of joules, convert into kilowatt hour. So that will be equal to 60,000 divided by 3.6 into 10 power 6 joules. That will be equal to 0.0167. 0.0167. What we are finding? Energy consumption in terms of kilowatt hour. That's it. Question number 9. A bulb rated 12 volt 24 watt operates on 12 volt battery for 20 minutes. Calculate the current, energy consumption. Okay, very simple. Listen, question number 9. First we'll write the given data. V is equal to 12 volts. Power is equal to 24 watts. Operate it for 20 minutes. 20 minutes. We have to convert this minutes into seconds. 20 into 60, 2 6 are 12, 2 zeros, so 1200 seconds. We need to find the value of current and easy. First we'll find the value of current. I is equal to, see, using all these data we have to find current. We can aramse find current using P and V, correct? See, use the second formula. P is equal to V into I, correct? V into I, we need the value of I is equal to P by V. So P is nothing but 24, V is nothing but 2, so answer will be 2 amperes. That's it. Second one, this is where you are going to get confused. See, till now we have found the electrical energy consumption in terms of kilowatt hour, but here the time is not given in terms of hours. Whenever the time is not given in terms of hours, that means we are going to find the electrical energy consumption in terms of joules. Keep that in mind. If the time is given in terms of hours, we have to find the energy consumption in terms of kilowatt hour. Now in this question it is not given in terms of hours, so we have to calculate the energy consumption in terms of joules. To find the energy consumption in terms of joules, the power should be in watt, time should be in seconds. Very simple, that keep that in mind. Energy consumption is equal to power into time. If it is in terms of kilowatt hour, it should be in kilowatt and this should be hour, but that is not given in the question. Time is not given in terms of hours, so we have to go for joule method only. Power will be, see, power is given 24 into time is given as 12,200, so this will be 28,800 joules. That's it. You need to understand when to find the answer of energy consumption in terms of kilowatt hour and when to convert that into joules. That's it. Question number 10. A current of 0.2 amperes flows through a wire whose ends are at potential difference of 15 volts. Calculate the resistance of the wire and heat energy produced in 1 minute. So first we'll write the given data. Question number 10. So here I is equal to 0.2 amperes, voltage is given as 15 volts and time is also given for 1 minute, that is nothing but 60 seconds. So we need to find R, first sub question. Second sub question, we need to find heat energy generated. Okay, now see, using current and voltage, we can aramse find resistance according to Ohm's law. So R is equal to, first sub question, R is equal to V by I. So what is V? That is 15 divided by current 0.2, that will be 15 divided by 0.2, that will be 75. What we are finding? Resistance, so unit will be ohm. Second one, we need to find H. What is H? Heat energy generated. Formula is I square R into T. All the values are there, right? I square it is given. Just now we found R, T is also given. I is 0.2 square into R, that is what we found now, 75, into time. Time should be in terms of seconds, so that is 60. So 0.2 into 0.2 into 75 into 60, answer will be 180 joules. That's it. See, if you know the concept, aramse you can find answers. Question number 11. What is the resistance under normal working condition of an electric lamp rated at 240 volts, 60 watt? Okay, if two such lamps are connected in series across 240 volts main supply, explain why each one appears less bright. Okay, first we'll solve the first sub question, then I'll explain you the second sub question. See, for the first sub question, what are the given data? We need to find resistance and voltage is given. V is equal to 240 and volts and power is equal to 60 watt. Okay, so R is equal to, using voltage and power, R is equal to V square by P, correct? V square by P. So V square is nothing but 240 into 240 divided by power. Power is nothing but 60. So the answer will be 960. What we are finding? Resistance, so unit will be ohms. Now we'll talk about the second one. If two such lamps are connected in series of 240 volts, explain why in each appears less bright. Listen, whenever you connect, now we have found the answer for one lamp. Now they are telling those two lamps are connected in series. Okay, and the supply is 240 volts. Now these two, see, this diagram is not required in the exam. these two are connected in series with the 240 volts. We know in series connection voltage will get divided, so this will receive 120 volts, this will receive 120 volts. What is the rated voltage? 240. How much it is receiving? 120. See, your capacity of eating chapatis are 5. If I give you only 2 chapatis, your activeness will be less, correct? In the same way, the rated voltage is 240 and we are supplying only 120. That's why the brightness will be less. So how can you write it in the exam? In series connection, the supply voltage will be divided into 120 volts for each lamp. We are supplying less voltage than the rated voltage. That's why brightness will be less. That's it. Question number 12. Two bulbs are rated 60 watt 220 volt and 60 watt 110 volt respectively. Calculate the ratio of their resistance. Very easy question. These kind of questions we have solved from the beginning. The ratio problem. See, whenever they are talking about ratio, we'll get to know it will be 1:2, 5:7 something. Okay, that means we will get is to. The same question can be asked in the different way. Compare their resistance. If they tell compare the resistance also, comparison means ratio only. Now we'll write the given data. Question number 12. So one is power 60 watt and voltage 220. Then the second one is power 60 watt and voltage will be 110. Okay, now we have to find the resistance in both the cases and then we have to find the ratio. Listen, we'll take it as P1, P2, V2. So that will be R1. For to find R1, say using power and voltage, this formula, correct? So this will be V square by P. V is 220 square by P, that is 60. See, when it comes to ratio, don't solve the numbers, okay? Don't solve it because somehow it is going to get cancelled. Because here if you solve it, you may get the decimal value, and in this, when you get the decimal value and you have to find the ratio, it will be very difficult task. So keep the answer like this only. Now we'll go for R2. R2 is equal to P, V square by P, correct? So that is V square by P. So that is nothing but 110 whole square by 60. Now what do you mean by ratio? R1 by R2. What is R1? That is 220 square by 60. This will be 110 square by 60. See, I can write this one. First fraction I'll write it as it is. 220 square is nothing but 220 into 220 by 60. So instead of division, I'll go for multiplication. I'll take the reciprocal. So this will be 60 by 110 into 110. 60 will get answers. See, 0, 0, 0, 0. So 22 into 22 by 11 into 11. 11 ones are 11 twos are 11 ones are 11 twos are. So what is the answer? 4 by 1. So 4 by 1 is nothing but 4:1. Question number 13. An electric bulb is rated 250 watt and 230 volts. Energy consumed in 1 hour we have to find, and second sub question. So first we'll solve the first sub question, then we'll go for the second sub question. See, question number 13. Power is given as 250 watt and voltage is given as 230 volts. This is not required. And first sub question A, energy consumption in 1 hour. Okay, that is what we have to find. Listen, energy consumption it is given in terms of hours, right? So EC is equal to power into time. Power should be in terms of kilowatt, time should be in terms of hours. So power is 250, that is in watt. We need to convert into kilowatt. 1000 into time 1 hour. So 250 by 1000, that is nothing but 1 by 4. 1 by 4 is nothing but 0.25 kilowatt hour. That is nothing but energy consumption in 1 hour. Now we'll go for the second sub question. The time in which the bulb will consume 1 kilowatt hour energy when connected to 230 volts. Don't worry about this 230 volts. Now we'll talk about the energy and this one, time. Listen, in 1 hour the energy consumption was 0.25 kilowatt hour. Now they are telling if this 0.25 kilowatt hour converts into 1 kilowatt hour, for 1 kilowatt hour how much time it will take. Very simple. In mathematics we have learnt unitary method, right? Cross multiplication. That is what we are going to use it here to get the answer. Listen, I'll use it, then you will understand. For 1 hour, okay, the energy consumption will be 0.25 kilowatt hour. They are asking for 1 kilowatt hour how much time it will take. Okay, that is nothing but x. Go for cross multiplication, we'll get the answer. See, these, the 1 into 1, 0.25 x. So x is equal to 1 by 0.25, that will be 100 by 25 is equal to 4 hours. That's it. See, very simple. Not all the time you should go for calculation method. Sometimes without calculation also you will get it. Question number 14. 3 heaters, each rated 250 watt, 100 volts are connected in parallel to 100 volt supply. Calculate the total current taken from the supply, okay, the resistance of each heater, the energy supplied in kilowatt to the 3 heaters in 5 hours. So first we'll go one by one. See, first we'll write the given data. Question number 14. Power is equal to 250 watt, V is equal to 100 volts, and we need to find the current. Okay, so this current should be total current. See, first of all we'll find current in each heater, okay, then we'll multiply by 3 because they are given 3 heaters, right? So first we'll find the current for one heater, then we'll go for multiplication. Listen, current in each heater, okay, we have to write that current in each heater or one heater is equal to, see, using voltage and power we can aram se find current according to the second formula. Now I is equal to P by V. P is nothing but 250 by V. V is nothing but 100, right? So this will be 2.5 amperes. This is in current in one heater or each heater. Now they are not asking current in each heater, they are asking current in total heaters, the total current, that is, see, I is equal to total current is equal to 3 into 2.5, so that will be 7.5 amperes. That's it. This is the final answer, total current. Second one, the resistors of each heater. So we are not going to find the complete resistance, we are going to find only the resistance of one heater. So R in one heater is equal to, see, we have current and voltage, we can aram se find it. So R is equal to V by I. V is 100, I is 2.5, so the answer will be 40. What is the unit for resistance? That will be ohms. That's it. So third sub question, the energy supplied in kilowatt hour to the 3 heaters in 5 hours. So we need to calculate the energy consumption by all the 3 heaters. So first we'll find the energy consumption by one heater, then we'll multiply it, we'll get the answer, and the time they have given is 5 hours. See, to find energy consumption, okay, we need two things, power into time. Power should be in kilowatt and time should be in terms of hours. Power is given as 250, that is in watt, we need to convert into kilowatt, so divided by 1000 into time. Time is given as 5 hours. So energy consumption, listen, 0 0 get cancels, 5 1s are 5 20s are, so 25 divided by 20, that will be equal to 1.25 kilowatt hour. Okay, 1.25 kilowatt hour. So what is this? This is energy consumption by one heater, correct? So we need to find the total energy consumption by all the 3 heaters. So this 1.25 into 3, answer will be 3.75 kilowatt hour. That's it. This is the final answer. See, if you know the concept, just applying the formula, substituting the values, getting the answer. That's it. Question number 15. A bulb is connected to a battery of potential difference 4 volts and internal resistance 2.5 ohm. A steady current of 0.5 flows through a circuit calculate. First we'll write the given data. Okay, this is question number 15. What are the given data? Potential difference, nothing but voltage, that is 4 volts, and internal resistance they have given. See, resistance is different, internal resistance is different. You will understand this concept whenever we solved the numericals from electricity part B numericals. Okay, in that question, in that concept, we have understood what is internal resistance. Internal resistance is nothing but the resistance of the battery, that is different, and resistance of the circuit is different. Internal resistance will be denoted as small r, that is given as 0.25 ohm. Now the steady current is given. Steady current is nothing but normal current only, don't worry about it. I is equal to 0.5 amperes. Okay, now these are the given data. Now we have to find total energy. First sub question, total energy supplied by the battery in 10 seconds. What do you mean by supply? See, we till now we have understood energy consumption, total energy consumption in few seconds or few minutes or few hours, but they are talking about total energy supplied. See, if I give you 5 rupees, you will take that 5 rupees. That means I am going to consume that 5 rupees. So total energy consumption is equal to the total energy supplied. Both are same. So we need to find EC. The time is given as 10 minutes. So EC for 10 minutes. Okay, see, whenever the time is given in terms of minutes, the answer should be in terms of joules. Correct, energy consumption answer should be in terms of joules. If it is in terms of hours, time is in terms of hours, energy consumption should be in terms of kilowatt hour. So now it is in minutes, so we need to find the answer in terms of joules. Okay, so time is given. To find energy consumption, we need power and time. Correct, power is not there, power is not given. See, using voltage and resistance we can aramse find power, but this is not the resistance, this is internal resistance. So don't use this R to find power. So use V and I to find the power. See, power is equal to V into I. Voltage is 4, I is equal to I is equal to 0.5. The answer will be 2 watt. Power is given as 2 watt. So energy consumption is equal to power into time. See, time is in terms of minutes, so power should not be in terms of kilowatt hour, it should be in terms of watt only. Okay, if the time is in terms of hours, power should be in terms of kilowatt. Okay, now the time is in minutes, so time should be converted into seconds, power should be in terms of watt. So this is 2, time 10 minutes, so it is 600 seconds. So those two will be 2 into 600, that will be 1200 joules. That's it. Next, second sub question, the resistance of the bulb. R of bulb. See, internal resistance is given. Okay, resistance of the bulb, how we can find it? First we have to find the total resistance. In that total resistance, if we subtract internal resistance, we will get the resistance of the bulb. So first we need to find the total resistance. How we can find it? Listen, this is R total minus R internal. Will get the answer. R total is nothing but, see, R we have to find normal R, that we can aramse find using V and I. Correct. This is V by I minus, what is that internal resistance? 2.5. Okay, V by I. So V is 4, I is 0.25 minus 2.5. So this will be 8 minus 2.5. Answer will be 5.5 ohm resistance. That's it. Okay, you understood? See, whenever they ask particular resistance, okay, about resistance in bulb like that, we have to find the total resistance of the circuit, subtract internal resistance. Okay, now total resistance, how we can find it? Using V and I. Using those two we can find resistance. That resistance minus internal resistance will give us the resistance of the bulb. Now the last part, see, energy dissipated in the bulb in 10 minutes. What do you mean by energy dissipated? See, energy dissipated means energy wasted. Okay, energy wasted in non-useful form. Okay, so what do you mean by that? Energy dissipated means heat energy. See, whenever we use any electrical appliances, heat will be generated, that will be wasted, correct? That is nothing but energy dissipated. So whenever they talk about energy dissipated, that means we have to find heat energy. So H is equal to I square R T. Okay, so here I square is equal to I, what is I? 0.5 whole square, R just now we found it, that is 5.5. Time, it is given in terms of minutes, 10 minutes, so it is 600, so that will be 825 joules. That's it. Question number 16. Two resistors A and B are of 4 ohm and 6 ohm respectively are connected in parallel. The combination is connected across 6 volt battery of negligible resistance. Calculate the power supplied by the battery, and there is one more sub question. First we will write the given data. Question number 16. There are two resistors. Resistance R1 that is 4 ohm, resistance R2 that is 6 ohm, and voltage that is 6 volt. Okay, now we need to find the power supplied by the battery first. See, two resistors are connected in parallel, that is the important logic, like this. Okay, if these two are connected in parallel, we need to find the power. Power is equal to V square. See, I is not given, so voltage is given and two resistance we have. We have to calculate the equivalent resistance, then we have to find the power. How do you calculate equivalent resistance? That is what we have learnt in part B of electricity chapter. Now we are not going to learn that, you just going to calculate. One is 4 ohm, another one is 6 ohm, they are connected in parallel. So 1 by Rp, Rp is equal to 1 by 4 plus 1 by 6. The LCM will be 24 and this will be 10. So we have to take the reciprocal because it is 1 by Rp. So Rp is equal to 24 by 10, answer will be 2.4 ohms. So the value of this resistance, okay, the complete resistance is 2.4. Next, here we need to find the power supplied by the battery. Power in the battery is equal to, we have V and R. So the formula which we are going to use it, fourth formula, P is equal to V square by R. V square is equal to 36, R is equal to 2.4. See, these two resistance we should not use because these two are connected in parallel. If they are connected in series, just we have to add it and get the complete resistance. Now these two are in parallel, we have to find the parallel answer. So 36 divided by 2.4 will be 15 watt. That's it. Now we'll go for the second sub question. Power dissipated in each resistor. Power dissipated in each resistor. Listen, this is the power from the battery. So we took the complete resistance. Now they are talking about power dissipated, power wasted. Dissipated means power wasted in each of the resistor. So we'll use separate resistors only. The same formula, V will be correct, same, R will be completely different for two different cases. See, power in R1. Okay, power dissipated in R1, that will be V square by R1. So V square, that is 36, V is 6, so V square will be 36, R1 is 4, so this will be 9 watt. The same question, power in R2, the same formula, V square by R2, V square is 36 and the resistance is 6, so it will be 6 watt. That's it. Question number 17. A battery of EMF 15 volts and internal resistance of 2 ohm is connected to two resistors of resistance 4 ohm and 6 ohm joined in series. Find the electrical energy spent per minute in 6 ohm resistors. Okay, listen. So first we'll write the data and also the diagram. Diagram will also help us to find the answer. Listen, they are not asking the diagram, but it will definitely help us. A battery of EMF 15 volts. See, I'll draw the diagram instead of the writing data. There is a battery and there are two resistors connected in series. Okay, the battery resistance is 2 ohm, internal resistance is nothing but the battery resistance, and voltage is 15 volt, and they have given two resistors, one is 4 ohm and is another one is 6 ohm, and there is a current flowing through. See, these kind of questions will be very easy for you if you have solved 8B numericals. Okay, now listen. So this is the given data. We need to find the energy, electrical energy spent per minute in 6 ohm resistance. Electrical energy spent means electrical energy consumed, okay, in 1 minute. That too we are asking about 6 ohm resistance. Okay, see, first to find electrical energy we need power. We need power and time. Correct. Time is given as 1 minute. Per minute means 1 minute, that is 60 seconds. So whatever the energy we are going to find, that will be in terms of joules, because time is in seconds or minute. Now we'll talk about the question. Energy consumption or energy spent in 6 ohm resistance, very important. Listen. So the formula goes like this: power into time. See, we have voltage, complete voltage, and we have resistances. So to find the resistance, first we'll find the resistance, then we'll talk about the remaining things. All the resistors are connected in series. So in series we know we have to add them, we have to include internal resistance also. So complete resistance is equal to 2 ohm plus 4 ohm plus 6 ohm, that will be 12 ohm. So resistance we found, we have voltage, we can aramse find power. Correct? Completely wrong. Why? Because we know in series connection voltage, whatever the voltage we have, that will divide at each appliances or each resistor. So we are talking, see, if they are talking about energy consumption, then we have voltage and power, resistance, we can aramse find power, and we have time, we can aramse calculate the answer. But they are asking energy consumption in 6 ohm. So whatever the voltage we are using, if we use it, the answer will be completely wrong, because voltage, whatever the voltage we have, that will be divided. So what will remain constant here? Current remains constant in series connection. See, all these basics are important. That is what we have learnt in concept videos. That is why I'll suggest always concept videos. Current remains constant, we'll find the current. So we have total resistance, total voltage, current will be equal to I is equal to V by R. V is 15, R is 12, so answer will be 1.25 amperes. That's it. So now we got current remains same. Using current and this resistance, we can aramse find power. Correct? Using the third formula, I square R into T. We are using the total current, because current remains same in the series connection. So I is equal to 1.25 square, and R is not the total resistance, they are talking about the particular resistance, right? That is 6 ohm into 6. Time is 62.5. So what we are finding? Electrical energy consumption, and time is in terms of seconds, so answer will be in terms of joules. That's it. Question number 18. Water in an electric kettle connected to 220 volt supply took 5 minutes to reach its boiling point. How long will it take if the supply had been of 200 volts? See, this question, whenever you read it, you will definitely get confusion. I also get confused, but once you look into it properly, the given data, see the given data, voltage is given and time is given. See, time is given in only two formulas, heat energy and electrical energy consumption. If this question is related to heat energy, they will definitely use the word heat or how much heat is generated, all those things. If that is not given, then definitely it is related to electrical energy consumption. So question number 18 is related to electrical energy consumption. Now they are talking about two things. Okay, voltage and time. Correct? We need power and time. How we can get power using voltage? Voltage into current will get the value, or else voltage into resistance. But in this question, which one we have to consider? Whether voltage and time to find power, or voltage and resistance to find power. This is completely wrong. Why? Because if the voltage changes, they have given two voltage. So if the voltage changes, current will also change. But if voltage changes, resistance of the wire will not change. This kind of question we have solved earlier also. So we are going to use this method. This is very much important. So whether you to use this formula or this formula, if you use this formula also, you will get the answer. That will be completely wrong. Why? Because if you use this one, voltage changes. See, initially it is 220, now it is 200. So definitely current also changes. So we cannot use this formula. and the value of resistance is not given, we'll apply in the formula, we'll see what happens. See, first they have given voltage as 220 volts and time as 5 minutes. Okay, then they are asking voltage is reduced to 200 volts and they are asking how much time it will take. And in both the cases we have R, we don't know R, we don't know R, and only thing we know is resistance in both the cases remain same. That is what we are going to use. Okay, so voltage, energy consumption in the first case, this case EC is equal to V square by R, correct, to find power into T. Okay, this is first case, and in second case the same thing. So V square by R. So here V square is 220 square by R into, they are talking about 5 minutes, right? So 5 minutes is nothing but 5 into 60, 300. Next here into time, that is what the time is only we are going to find, and here V square is 200 square, we don't know R, into time, that is what we are going to find. Whenever in both the cases, see, this is the equation number 2. In both the cases we are finding electrical consumption only. So we can aramse relate this equation to this one. These two are equal because electrical consumption answer in both the cases we are going to get will be equal. So equation 1 will be equal to equation 2. This is equation 1. 220 square R into 300 is equal to 200 square by R into T. Okay, R and R will get cancelled. This will be 220 into 220 into 300 is equal to T. You move this 200 this side, 200 into 200, for 2 zeros get cancelled, 1 0 1 0 1 0 1 0. So we are remained with 2 11s are 2 11s are 11 into 11 into 3. So the final answer will be, see, if you complete it 11 into 11 into 3, we will get the answer as T is equal to 363 seconds. 363 seconds, you can convert that into minutes also, or you can keep it here also. See, in the question they have given one more time as in minutes, right? In minutes, so we'll convert this also in minutes. If time is 363 seconds, if you convert into minutes, it will be. Question number 19. An electric toaster draws a current of 8 amperes in a circuit with a source of voltage 220 volts. It is used for 2 hours. Find the cost of operating the toaster if the cost of electricity bill is 4.5 kilowatt hour. Okay, listen. First we'll write the given data, then we'll go for the question. Question number 19. The current is I is equal to 8 amperes. Then voltage is equal to 220. Then time is equal to 2 hours. See, if the time is given in terms of hours, we are finding electrical energy consumption and nothing but electrical energy bill. So the energy should be in terms of kilowatt hour. Then operating the cost, rupees is equal to 4.5 rupees for 1 kilowatt hour. 1 kilowatt hour. So we have to find the complete bill. Listen, see, first we got to know that it is electrical energy consumption related question, and we have to find the bill, electricity bill. Electricity bill is equal to EC into number of days. It is not mentioned here, so we can neglect it, into rupees. What is EC? Electrical energy consumption, that is nothing but power into time. Time here it is given in terms of hours, so power should be in terms of kilowatt, and into number of days, okay, here rupees into rupees. So we don't have power, correct? We don't have power. How we can find power? Using V and I. V into I will get it as power. So power is equal to V into I. Whatever the power we are going to get, that will be in terms of watt, but we want kilowatt, so divide it by 1000 into time. Time is nothing but 2 hours, correct? 2 into rupees is nothing but 4.5. So V into I, that is 220 into I is nothing but 8. It divided by 1000. Why we have dividing by 1000? To convert into kilowatt hour into 2 into 4.5. So once we solve this one, the answer will be, the final answer will be, so electrical bill generated will be 15.84 rupees. That's it. See, they are not talking about the whole month. They are talking about, if that is not given, they are talking about only one day. So for one day, electrical bill will be 15 rupees 84 paise. That's it. Question number 20. An electric kettle is rated 2.5 kilowatt, 250 volts. Find the cost of running the kettle for 2 hours at 5.4 per unit. Okay, listen, this question is very easy because all the data are given. Power is given in terms of 2.5 kilowatt only. Okay, power value in terms of kilowatt, it is given directly, and voltage is given. That is not useful for this question, and it is run for 2 hours, and rupees for 1 kilowatt hour is 5.4. okay, 5.4 rupees. Now we have to calculate the bill. Bill is equal to EC, electrical energy consumption, into number of days. Number of days is not mentioned here, so rupees. So EC is nothing but power, that should be in terms of kilowatt, into time, into this rupees. Correct. So all of them are in proper unit, so we can aram se generate the electricity bill. Now power, that is 2.5 into, that is in kilowatt hour, so no need to convert into kilowatt hour. Time is already in hours, so that is 2 into 5.4 rupees. The answer will be 27 rupees. That's it. Our last question. A geyser is rated at 1500 watt, 250 volts. The geyser is connected to 250 volts main. Calculate the current drawn, the energy consumed in 50 hours, and we have to calculate the bill also. Now first we will write the given data. Question number 21. Power is 1500 volts. Voltage is 250 volts, and we have to calculate the current, EC, and EC means energy consumption, and bill. Okay, first we will go one by one. First sub question, I is equal to, see, using power and voltage we can aram se find I, right? I is equal to power by voltage. Power is equal to 1500 divided by 250, so the answer will be 6 amperes. Next, second sub question, we have to find the electrical energy consumption. Energy consumption, EC is equal to, see, in the exam you write it in full form. EC is equal to power, that should be in terms of kilowatt, and time should be in terms of hours. Power is given as 1500, that is in watt, so divided by 1000 to convert into kilowatt. Next, hours, that is given in terms of time. Time is given in terms of 50 hours, correct? So that is 50. So 2 zeros, 2 zeros, 1 0, 1 0, 15 5s are 75 kilowatt hour. Next, we need to find the bill. Bill is equal to EC into rupees and into number of days. Number of days is not mentioned in the question, so the value of EC, electrical energy consumption, just now we found it, that is 75. According to the bill formula, number of days should be there, but it is not mentioned in the question. We will take it as 1, and rupees is given, rupees is 4.2. So the answer will be 315 rupees. That's it.